A very good morning, good afternoon and good evening my dear friends. Welcome to this 3-part lecture series, 3-part in the sense that it will have 3 different courses titled Data Analysis and Decision Making, as you can see on the screen on the slide. And this would be when all of you have gone through this the general syllabus, which was very brief as mentioned from my side. So, it will basically have 3 big components. One is the statistics part, one is the operation research part, and one is basically the use of other non-parametric techniques and computing part. So, this decision analysis and decision making, which we can make as say as DADM 1, would basically be the statistics one which will be floating. And we will go basically may pay special emphasis on multivariate statistics, but obviously it needs some background. So, for the background we will cover few sessions, few lectures for the univariate statistics, and for that I will go slowly through data analysis, how what we mean by probability, then discrete distribution, and continuous distribution, concept of expected value, so on and so forth. This course of DADM 1, DADM 2 and DADM 3 would basically be under the NPTEL MOOC, and they would be run back to back in 3 semesters or sessions. The first one is DADM 1, which will only focus on statistics, and obviously the linkage between DADM 1, DADM 2 and DADM 3 would be such that people can utilize the concept of so called data analytics and data analysis in a much better way, trying to utilize how things or the concepts more from the practical point of view and less from the theoretical point of view. That will be our focus, can be utilized for different areas of problems, say can be it in engineering, can be it in marketing, can be in sociology, can be in say for example quantitative finance, can be in operation research, and so on and so forth. So, also to give a very brief background about myself, I am Raghunandan Sengupta from the IME department at IIT Kanpur, and this would be the first course, as I said, that I will be covering DADM and continuing with 2 and 3. So, this is 1. Before I go through the syllabus, you should remember for all the courses which I have taught like TQM 1, TQM 2, project management, and initially the quantitative finance, they were of 20 hours lecture. So, 20 hours basically half an hour each lecture for 1 week. It will be 5 courses, 5 lectures rather than course, and then there would be an assignment. But these 3 back to back courses, which I would basically say they are a one big envelope of set of a basket which consists of 3 different topics, would be 30 hours each. So, 30 hours each would basically be 60 different lectures. Each lecture would be of half an hour, and again the same thing would be repeated, and for each week we will have 5 lectures of half an hour each. So, we will continue for more than 8 weeks what we have done for the 20 hours one. So, first I will go very briefly through the syllabus of DADM 1. Then cover few of the textbooks. So, this let me tell you, these textbooks are not exhaustive, there are different type of very classic books in the market, but we will try to basically give some sample of the textbooks which one can use, and definitely utilize the problem solving, utilize them from the concept of theory to understand that how DADM 1 can be understood in a general sense and where you can apply. So, we will consider very briefly the concept of elementary probability theory, we will consider the concept of conditional probability and what does conditional probability mean. We will go through the Bayesian concepts very briefly and to the point. Then we will consider the concept of discrete and continuous random variables, what we mean by random variables, and what the concept of random variables, probability theory, chance, relative frequency, what they mean. I will cover that also. Then we will go briefly into generating functions and how generating functions give us some concept about the different type of moments of the distribution. So, the moments, as I mentioned, it would be The first moment would be something to do with the mean or the central tendency. It can be median, it can be mode also. Then we will consider the concept of dispersion, standard deviation, variances. Then we will go to the higher moment, third one, fourth one, which will be skewness, kurtosis, and we will also see that how these moments can basically be obtained from the generating functions and what their concepts and utilization for the first, second, third, fourth and higher moment would be. We will consider the central limit theorem and some of the limit theorems, how they can be utilized, but maybe if we are not able to cover them from the practical sense, but I will definitely try to give you a flavor from the theoretical and the conceptual sense. Then we will consider different functions of random variables, how they can have implications in our discussion. Then we will go to the basic joint distribution random variables for the discrete case, for the continuous case, and we will keep it limited to the discrete case, and for the continuous case we will keep it limited to the bivariate normal distribution. Then we will go to the concept of sampling theory and why sampling theory is important, and as we will discussing we will also again repeat what we will be obviously going through beforehand, the concept of sample, sample space, population and all this related concept, and we will basically lay main emphasis on the three main sampling distribution, which will be all coming from the normal distribution, would be the chi-square distribution, would be the F distribution, would be the T distribution. And we will also see that how the normal distribution, the normal deviate, chi-square, T distribution and the F distribution, they can be utilized in different type of problems and how we can use the tables to understand them. Then we will consider the method of statistical inference, the concept of how the concept of point estimation can be utilized, how the concept of interval estimation can be utilized, how the concept of hypothesis testing can be utilized, and obviously we will lay more stress on hypothesis testing. And when we are doing these three topics which are under the ambit of statistical inference, we will cover that what we mean by consistency, what we mean by unbiasedness and what their significance is with respect to the sampling distribution and the parameters and their estimates and what implications they have. We will go to the theory of point estimation, estimation of parameters, and as I mentioned what is the concept of unbiasedness and consistency, and as I also mentioned with theory of interval estimation will be utilized for different values of probability, for different p values. The hypothesis testing will be considered, and we will consider in the conceptual sense what we mean by a null hypothesis, what we mean by alternative hypothesis, which is H naught and H A respectively. We will consider very briefly the descriptive and deductive statistics which are utilized. We will consider the linear and multiple linear regression in though brief, and consider what are the assumptions, how they can be utilized. We will consider the analysis of area variance or ANOVA, and obviously some statistical packages of MATLAB and all these things we will use. We will come to the statistical packages later on, please have the patience. To further continue, we will consider the concept of different type of multivariate statistical analysis. We will consider the multinomial distribution, the multivariate normal distribution, the multivariate T distribution and the corresponding statistics for that. The wizard distribution and other distribution of the multivariate case would be considered, and what are the implications, with not going to the theory as I am repeating again, it will be more from the practical sense. We will consider the multivariate extreme value distribution, EVDs of type 1, type 2, and where they are used, we will lay more emphasis on usage. We will consider the Coppola theory and how multivariate distribution Coppola theory are being utilized. We will consider the multivariate analysis of variance, MANOVA, multivariate analysis of covariance, which is MANCOVA. We will also consider later on at the last part of this course the different type of multivariate statistical methods like conjoint analysis, cluster analysis, multiple discriminant analysis, multidimensional scaling, factorial analysis, structural equation modeling, and so on and so forth, and how they can be utilized for different type of multivariate statistical studies. Now, as I mentioned, there are 1001 books in the market, some are classic books. So, obviously, it would be not possible to cover these concepts in many of the cases, but I will try to give you as far as possible their references for the classic books, and these classic books have been the cornerstone based on which many of the courses for masters, bachelors and PhD courses for different statistical courses are designed. But I will be very brief and to the point and definitely not go into the high end. So, some of the books, so obviously there are, again I am saying they are not exhaustive, I have a list of about 12-13 books. So, we will consider the book of Introduction to Categorical and Data Analysis by Agresti 2007, Anderson, which is a classic book in an introduction to multivariate statistical analysis, but obviously Indian versions are not available. We will consider Bentler and Chow, the practical use of structural modeling from the sociological perspective. We will consider the structural equations with latent variables book by Bolen, which is also a Wiley publication. The other books which will be considered for different type of multivariate statistics would be the Chatfield book about multivariate analysis, the Duran book which is a survey of cluster analysis techniques which I use. A very good book for the initial statistical concept would be the Freund book, but obviously this sequence of the books are named as per their the surname of the author. So, it is not divided into areas where I am going to consider. We will consider the methods of statistical data analysis of multivariate observations by Ganadesikan. So, this will also be from the multivariate statistical point of view. A very good book in applied multivariate statistical techniques and their applications is Hardley and Simmer, and another one which is the 10th one, which is Johnson and Wickand, which is a classic book, though old, it is definitely used. Multivariate distributions and the application by Koch and Nadarza is a classic book from Cambridge. We will also consider the Render, Stair, Hanna's quantitative analysis for management, which is also to do with univariate statistical techniques, and Gaff Saver's multivariate observation book, which is also an old book, would be another one for the multivariate one. So, if you see these 13 books, their main stress is basically on the area of multivariate statistics, and obviously that is the main focus of this book. So, we will try to wrap up the initial introduction for univariate statistics about hypothesis testing, as I said, then about point estimation, discrete distribution, continuous distribution, expected value, moments as fast as possible. Some of the software languages which are very heavily used in statistics would be the R. So, R is a free software, anybody can download it and use it. We have the SPSS, we have the SAS, and another very good tool is the MATLAB, which will be utilized to do both R and MATLAB would be utilized to solve the problems from the point of view of multivariate statistics and univariate statistics book. So, let us consider an example. So, consider the news paper vendor. So, he wants to maximize his profit. So, what is the problem? The problem is the news vendor buys papers daily in the morning and he sells them. So, consider he buys them at 2 rupees, whether it is Times of India, Hindu, Statesman, Telegraph, whatever it is, and he sells them daily at, say for example, let us consider one price at 5 rupees. So, obviously for each paper, if it is sold, he or she makes a profit of 3 rupees. But consider that if he buys 10 different papers, 8 are sold. So, which means that 2 are not sold. So, obviously if 2 are not sold, he cannot sell them at more than the cost price. So, you have to sell them as papers, as just newspapers which can be utilized for other work. So, obviously he sells them at a loss. So, initially he brought them at some amount, sold them at a higher price if there is a market. For those amount which are not sold, he had to sell them at a less price. So, obviously the question arrives or comes to our mind is that what is the optimum number of papers he should buy in order to basically maximize his profit. So, obviously the question is, which is unknown to us, is that what is the number of papers you should buy and what is the demand of the papers daily. Next, consider an example, a production manager, he wants to minimize the waiting time of jobs on machines and thus reduce inventory and costs. So, jobs are arriving, they are being processed and they are being basically packaged and shipped on to the customers end. Now, obviously depending on the demand of the customers, demand of the products, what is the cost price of the products, what is the availability of the products, obviously he will keep an inventory, but too high an inventory obviously would mean that he has to basically incur an inventory cost, and that would basically entail both depreciation, about security prices and so on and so forth, space constraints. So, his main question would be the production manager would ask himself is that what is the demand of the customers, based on that he will basically have the optimum number of products stored in the inventory, so that he can work them on the machines and sell them in the market without much of an inventory storages, such that he is able to reduce the inventory storage, plus he is able to reduce the lock in money which is being he or she is spending on the inventory, and such that costs are minimized and he is able to reduce his inventory. Let us consider a third example. A marketing manager wants to recommend the best chances of a product which is to be sold in the market, so that it will do well. So, obviously, he does not know the demand, he should know the demand. Like in the second example which I gave for the production manager, he should know about the demand of the customers. In the same way, the marketing manager should know the demand of the customer, and he will basically order products, raw materials which you want to basically order and work on them, or basically order some products he wants to sell in the market. Consider he is the marketing manager of one zone which is south of India, and he wants to basically have some white goods like fridge, TV and then washing machines he want to basically store in his distributor end, at his factory's end, where he wants to ship them to the retailers end from where they will be sold. So, depending on the demand of the customers, he will like to basically keep the minimum inventory as well as try to maximize profit, so that whenever a demand comes he is able to meet that, and if there is no demand, obviously technically and theoretically he should not have any products, because that would basically clog his money. But obviously, if he keeps less, so if a customer demand comes, he is not able to satisfy that, it is basically a lost sale for him. So, in these three examples which you saw, that we will always see that there is some concept or some quantity or some variable which is unknown, which is not known to you beforehand, that is basically random, and our main task is basically to pay some importance or note that how the demand, how the supply, how the inventory cost of these things can be considered in order to basically maximize the profit or minimize the loss or the cost. Now, all these things are basically dealt in the ambit of the subject of statistics. So, what we mean by statistics? The word statistics is derived from the Italian word stato, which means state, and statista basically refers to a person who is involved with the affairs of the states, based on which he passes his or her judgment. Basically, that is the concept of statistics, but considering the statistics has come a long way, statistics basically now encompasses different type of tools, different type of mathematical techniques, different type of concepts, and obviously computing has also become a very important factor, such that people can utilize numbers which are not deterministic, which are random, and basically can understand the randomness of these variables and make some judgments based on which some decision can be passed. So, decision means all the three decisions, like the vendor boy, the person who is in the production manager, the marketing manager, basically they can understand what is the number, so that they can optimize on their objective function, whatever the objective function is. Nowadays, statistics, which basically is in a plural sense, is the study of the qualitative as well as the quantitative data from our surrounding, be its environment, whatever the environment where we are operating, or any system where we are operating, so as to draw meaningful conclusions about the environment of the system, and such that we can give some information about the system based on which we are working. So, in the first case, environment is the papers are uncertain, how you will sell, you do not know, demand you do not know, you basically have to find out what is the distribution of the demand, and based on that you will make your decision. In the next example is basically what is the demand of the customers, based on that he will have the inventory. In the third example, it is the demand of the customers, based on this which the marketing manager would order the products which can be sold in the market. The word statistics also means in the singular sense. So, the first one was the in the pluralistic sense, plural sense. In the second example is in the singular sense. It means the body of methods that are meant for treatment of such data, such that we can find out some meaningful meaning or meaningful words, based on which we can do some mathematical analysis in order to study them. So, the main steps in the study of statistics are, so there would be a method of collection of data, it can be primary or secondary. So, if it is primary, we will basically go into the environment, collect the data and basically analyze the data, such that you have to basically pass on some meaningful judgment about the environment which you are going to study. In the secondary data, it will be the data which you are collecting from the primary source, like the government has the data you collected, or the census is the data you collected, financial stock markets has the data you collected, rainfall is the data you collected, humidity is the data you collected. So, based on that you try to study the environment, study the actual topic which you want to analyze, and basically pass some meaningful judgment. Next would obviously would be whether it is primary or secondary, you will basically scrutinize the data. So, you will try to scrutinize the data, whether they are missing data, whether the raw data has some errors, or whether they are spurious data, whether they are the data have been collected in the random fashion, or whether there have been some effect from the environment. So, obviously, you will try to analyze them and make it as clean as possible for our studies. Then obviously, the next step would come is basically the presentation of the data. It can be non-frequency type or frequency type, based on which you will try to basically portray to the set of persons who want to utilize the data in a best possible manner, such that information can be gathered or gleaned as soon as possible, or as easy as possible, or as fast as possible. The next steps after the presentation would be basically the analysis of the data through different statistical methods, techniques, which I definitely mentioned when we are going through the syllabus. It can be concept of probability, concept of inference techniques, can be hypothesis testing, can be multivariate statistical methods, whatever it is. Once you analyze the data, you want to basically conclude. So, whatever the analysis has been, you want to conclude and give some answers. So, the next step would be conclusions from the results thus obtained. So, based on which some decision can be taken, and in the later on steps you will try to basically modify, or modification of the statistical models and methods should be done depending on what are the results are obtained, whether the results which you are obtained theoretically are matching with the practical results. If they are not, obviously you will try to analyze what are the assumptions based on which you have done the modeling, what is the scrutiny you have done for the data, whether the raw data is absolutely free of error, whether that has been done. So, if that has not been done, obviously the models would not be exact, such that the discrepancy in the results of the models which you are trying to predict or give would basically be quite high with respect to the practical data or practical answer which you are getting. So, obviously there would be feedback loop based on which the results which you get from the theoretical sense and the practical sense, you try to match them and basically try to then change your model in order to basically suit and find out the assumptions based on which you are working are exact, such that they give near optimal or actually as close as possible results to the practical sense. So, the descriptive statistics which I mentioned was basically the presentation of the data can be done as non-frequency data and frequency data. So, obviously, we know the frequency is the numbers of times of occurrences, and non-frequency data would be that we are not using the concept of number of occurrences in order to present the data. So, non-frequency data, say for example, can be time series or historical data. Consider the case where the representation of the values of one or more variables like population of India, price of petroleum, price of mica, price of gold, the total the output of grains which is there for any particular state, say for example, the state of Odisha. So, what is the rice production of Odisha for the last 10 years? So, those would basically be non-frequency data or on the time series scale. For instance, we may be interested in knowing the population change over time, or the change of production of petroleum over time, or the change of production of paddy over time for Odisha, or maybe say for example, migration numbers happening between states. So, all these things can basically be the data which can be presented in a non-frequency format. So, let us consider this simple example, and there would won't be any calculation as such. I am just presenting the data in order to make you understand that how the data can be presented to you. So, non-frequency data, say for example, time series representation of the data can be for the Bombay Stock Exchange, the index which consists of 30 stocks. So, the closing price which you are considering starting from 3rd of January 1994 to 31st March 1994. We have the data as given. So, the BSE 30 close values are given on the y axis starting from 0 to 5000, and along the x axis we have basically the times. So, the histogram which you have basically it can be drawn in other way also. It gives you how the prices, if you follow the marker how it is varying, is basically the prices, how the BSE 30s indices prices change starting from almost the 1st of January 1994 till the end of March 1994. Non-frequency data can be of spatial series type also. It may be that the values of one or more variables are given for different individuals in a group for the same period of time. So, obviously, the time frame is same, but they are given for different individuals. So, you have to basically collate and collect them and present them in such a data that they make meaningful sense. But instead of considering the group as such, we may be more interested in studying the way the values of the variables change from individual to individual in that group, and such that we can find out what is the percentage change for that particular variable between groups which we are going to study. So, say for example, this is the non-frequency data for the spatial series representation of the data, where we have the fertilizer consumption for the states starting from Andhra Pradesh, Karnataka, Kerala, Tamil Nadu till Assam for the year 1999 to 2000 in metric tons. Fertilizer consumption is given along the y axis, where the minimum value is 0, maximum value is given as 35 lakhs, and along the x axis you have basically not the time, is basically the each and every individual the individuals which are there, which are the states, which is Andhra Pradesh till Assam, and if you see the variation will give you what is the actual consumption of that particular product, which is fertilizer, for all the different states in the year 1999 and 2000. Now, we will come to a few very simple examples of frequency data. So, we have the data on one or more variables for different individuals for different periods of time or for different points, but now we are more interested in the characteristics of the group rather than on the individuals in that group. In studying the, say for example, you want to study the IQ level of students in a school, we may be interested in such group characteristics as may be relevant, which is the percentage of the students with IQ or intelligent quotient higher than 130, or the percentage of students with average IQ less than 90. So, we may be more interested in trying to study what is the percentage, what is the number of such students having more than 130 and less than 90, or between, say for example, 90 and 130. Frequency data or a tabular representation can be given as another example. So, say for example, we consider India at a glance in its all economic parameters. So, we have the percentage of GDP which is given along the first column, which is the agriculture, industry, manufacturing, services, private consumption, government of India consumption, import, domestic saving, interest paid, so on and so forth. This is for the year 2003 and 2004. And based on that we are trying to finalize. So, in 1983 the agricultural consumption is given as 36.6 percentage, and it goes on to 2003 as 22.2 percentage. In the interest paid, it is basically 0.4 for 1983, and it goes to 2003, which is 18.3. So, if you see at a glance, you can find out what is the percentage change which we have. Frequency data or diagrammatic representation can be also be utilized. So, this is the most commonly used for representing time series. The line diagram, also called the histogram, is a graph showing the relationship of the given variable with time. So, there may be three types of line diagrams for the scale used for both the axes and on the coordinate system. They can be in arithmetic or the natural scale. One can be arithmetic, another can be the logarithmic scale, and the third way of representation can be logarithmic to logarithmic scale. A line diagram where the vertical scale is logarithmic, but the horizontal scale is of the ordinary type is called the ratio chart or the semi-logarithmic scale. When both the vertical as well as the horizontal axes are logarithmic, then the chart is called the doubly logarithmic scale, and we will try to study that in more details later on. So, with this I will end the first class and continue discussion about more about data representation and quickly go into the concept of probability and so on and so forth, so that we are in well versed and in a good position to start out the multivariate statistical techniques. Have a nice day. Thank you very much.